Okay, this is the key for Quiz1 version 2, version B. So we start out with another Venn diagram problem. In this case, it has a ring for whole numbers and it has a ring for less than 0. Less than 0 is just the same thing as negative numbers, right? So we can take all the negative numbers and we can put them somewhere in the circle. The two negative numbers are negative square root of 2 and negative 3. So the question is, does it go in the bigger part of the circle, which is outside the whole numbers, or does it go in the small part of the circle, which is together with the whole numbers? So is the number negative and whole? That would be true for negative 3. What about negative square root of 2? Is that a whole number? No, negative square root of 2 is like 1.414. It goes on forever. So that would be in the less than 0 circle, but it is not in the whole number circle. So that's how you put those two in there. Now in the whole number circle, you're going to have whole positive numbers and whole negative numbers. The only whole negative number here is negative 3. Okay, but there's these three whole numbers that are positive, including the natural number set n, which includes 0, 1, 2, 3, all the way to infinity. Whole numbers. Okay, so that goes there. 3 obviously goes there. What about 6 divided by 3? Well, remember, 6 divided by 3, if you're not good at division, 6 divided by 3 is 2. Sorry, I got this in scientific notation. So let's change back. Okay, so when we do 6 divided by 3, it's going to give us 2. Okay, so, and 2 is a whole number, so 6 divided by 3 also goes in the whole number circle. It's not negative, so it's in the big part, not in the small part. Okay, the small part is shared between less than 0 and whole numbers, so anything that is less than 0 and a whole number goes here. Anything that is only less than 0 goes here. Anything that is only a whole number goes here. Okay, if it's not either one, then you just put it outside. The R is the real number set, so it accepts everything out here. Okay, so square root of 2 is not a whole number and it's not less than 0, so it goes out here. Oops. Let's see if I can cover this. Okay, so so all these other three numbers go outside. 3 divided by 6 is a half, so it's not whole and it's not less than 0. 0.123, 123, 123 repeating, that is a rational number, but it's not whole and it's not less than 0. It goes outside. Square root of 2 is, 1.414. It goes on forever, never repeats. That's an irrational number. It's real, but it's not less than 0 and it's not a whole number, so that goes outside too. Okay, circle the numbers that are in the set Q. Remember, set Q is the rational number set, so that means any number that can be expressed as a fraction with whole number on top and on the bottom. Okay, so 2.1 over 2, is that a fraction with whole number on top and whole number on bottom? Well, it's not, but you can easily change this to whole number on top to whole number on bottom by multiplying by 1, or 10 over 10. Okay, so if you multiply by 10 over 10, the top is going to be 21, the bottom is going to be 20. Right, so 21 over 20 is a fraction with whole number on top and bottom, so that is a rational number. Okay, 1.444 repeating, that since it's a repeating pattern in the decimal, that can be converted to a fraction. Okay, remember doing that math trick in the worksheets. Okay, negative square root of 3 over 2, anything with a square root of 3 in it is probably going to be irrational. Okay, because the square roots that are not perfect squares are going to go on forever without repeating or terminating, and even if you divide it by 2, it's still going to be an irrational number. Even if you make it a negative, it's still going to be an irrational number. So this is not in the set Q. Pi minus pi, now this looks like it might be irrational, but if you take any number and subtract itself, it's going to be 0. So a 0 is rational. Okay? 0 can be a fraction, right? You just put 0 over any number, 0 over 1, 0 over 2, it's still 0, and it's a fraction. Okay? Round to 3 significant figures, 3, 2, 2, 5. Okay, when you do this, you're going to keep 3 significant figures. You're always going to start with the left one. So 3, 2, 2, you want to keep. Now what is this 5 going to do? Well, the 5 is going to affect the 2 by rounding it up, because, you know, 5 and over is going to round this number up. Okay, so we know that the first 3 numbers are going to be 3, 2, 3. Now what about the last number? We're throwing away the 5. What do we do then? Well, we got to put a 0 there to replace it, right? Otherwise it's not going to be approximately the same number. Okay, so 3,225 rounded to 3 significant figures is going to be 3,230. Now if we're going to round 9.948 to 1 decimal place, that means we're just going to keep the second 9, right? The first 9 we're going to keep. It's the whole number part. The first 9 after the decimal point, that is the first decimal place. We want to keep that. Okay, so the 4 and the 8 we are going to discard. Now the 8 we just completely discard. The 4 we're going to look at first to see if it affects the 9. Since 4 is less than 5, it is not going to round the 9 up. Okay, I know you guys want to take that 8 and round the 4 up, but anything after the first number that's going to be discarded, you're going to completely ignore. So the 8 you're going to completely ignore. Okay? One way to think about it is, okay, if you are going to look at all these numbers, look at a 48. Okay, is a 48 less than 50? Yes, it is. So it's just like saying, is 4 less than 5? Okay, it's not going to affect the number. Is 48 less than 50? Okay, so it's not going to affect the number. Okay, so it's not like 8 is going to round it up. You're just going to consider the whole thing, 48, to see if it rounds the number up or not. Or just completely ignore the 8. That's probably easier. Okay. Now there's 2 problems here to convert to fractions. Let's take the easy one first, 2.43. If we want to convert that to a fraction, the first thing we do is we just put it over 1. Now it's a fraction. It's not a whole number fraction, but it is a fraction. Okay. So now let's try to get it into a whole number fraction. Well, the top is 2.43. So all we have to do is multiply the top by 100 and the bottom by 100, which is the same thing as multiplying by 1, which is fine to do. And then you're going to get 243 on top and 100 on the bottom. Okay, and so now we have a whole number fraction. So now we've satisfied what they asked us to do. All right. The next one, it asks us to convert 1.24343 to a whole number fraction, which we use the math trick, multiply it by 100, and it shifts the decimal in 1.24343 over 2 places, and so we end up with 124.343 minus 1.243, and the difference is 123.1. And on the left side, we're subtracting x from 100x, and then we get 99x. So when we divide that out, we get x equals 123.1 over 99. That's not a whole number fraction, so we multiply the top and the bottom by 10 each. The top becomes 1231, and the bottom becomes 990. Okay, the last number in the regular part of the quiz is 782,000. We're going to change this to a scientific notation. I said standard form here, which our book is going to call scientific notation standard form. So I'm getting you ready for that. The left part is going to have all the significant figures, and I said here that it's going to have 4 significant figures. Well, if you look at this, you're going to say, but there's only 3 significant figures, 782. After that, it's a bunch of zeros, which are just placeholders. Well, in this case, I'm telling you that there's 4 significant figures. So the first 3, which are obviously significant, you keep those, and the first 0 you're also going to keep. Okay? So when you do that, you got 7820 is significant, right? So you put that in the first part of the scientific notation, and then the decimal point has to go between the first and the second number, right? So you put that there, and then the 10 to the 5th tells you how many decimal places to move it over. Let's just check to see if that's right. We're going to start here between the 7 and the 8, and then we're going to jump 5 positions. 1, 2, 3, 4, 5. So there's going to be 2 zeros after that, and that matches with that. Okay. Now remember, you can use your calculator to check things like this. We're going to put the scientific notation that you guessed here, 7.82 e to the 5th, and we can check to see that it's right. Or you could even like do the conversion here to scientific notation, although it's not going to do the significant figures. You would do that by putting the mode to scientific notation, and then you would put in the number 782,000, and then that you would get out 7.82 times 10 to the 5th, which is right. The only thing it doesn't tell you is how many significant figures. Well, I told you it's 4 significant figures, so you just like add those by hand, because calculators are not good at figuring out scientific or significant figures. It only does the calculation. Okay, now these last two, the easiest way to do is just do it on the calculator. So we talked about this in class. Just type these numbers in using the E key. So 6.2 e to the negative 5th divided by 7.3 e to the 3rd, and then we get 8.49 times 10 to the minus 9th. The only question is how many significant figures do we keep, and it says 3 significant figures. So that would be 849, and the next one would be 3. Does this 3 affect the 9? Well, it's less than 5, so it doesn't. So we just keep 849 times 10 to the minus 9th. In this addition problem here, 5.62 times 10 to the 5th, we can just put that in the calculator too. 5.62 times e to the 5th plus 3.1 e to the 3rd, and we get 5.651 times 10 to the 5th. We just need to do the significant figures part separately, so we need 3 significant figures, so the 4 significant figures here are too many. We just take off that last one, and then we're left with 5.65 times 10 to the 5th, and that's the end.